right, guys, second part of your test, which is tomorrow, is going to be 6 questions, and it's inequality. So we have to graph and write interval notation our answers. So if you look at something like number 1, all right, number 1, all of these are linear, meaning they're x to the first power. So when it's linear, it's fairly straightforward and fairly simple. If you have x in the middle and you have stuff on either side, you need to get x by itself. So we're going to subtract 5 from everything. So -4, -5 is -9, right? Less than -3x, less than or equal to 12. Everybody with me? Now we're going to divide everything by -3. If I divide or multiply by a negative number, what do we do to the signs? We have to flip them. So this becomes 3. I'm going to flip this to be greater than. This cancels out. I have x, and then I'm going to flip this, and this becomes -4. Everybody see that? You can rewrite this. If you read it backwards, if you start with -4, you can rewrite this as -4 less than or equal to x less than 3. Either way is fine. Now, in order to graph it, okay, we have a closed dot here and an open dot here. Why is the first one closed but the second one's open? Why is the first dot going to be closed and the second one open? Yes, because there's an equal sign underneath. Absolutely. So I'm going to have -4 here. Then I have 0. And then I have 3. Is everybody with me? All right. So we have an open sign at a closed sign at -4. An open sign at 3. And where am I going to color? In the middle, because that's where x is. And then if you were going to write your interval notation, you guys would tell me it was from bracket -4, comma 3 with a parenthesis. Bracket, closed dot, equal to underneath. Parenthesis, open dot, not equal to. So for number 1, a question like this is what I'm looking for your answer. All 3 of these things. Questions? All right, number 2, or 28, whatever. Same thing. This is a linear. It's to the first power. So I'm just going to get x by itself. I'm going to add 2 to both sides. +2 + 2. So I have 3x is greater than. -11 and 2 is -9. Divide both sides by 3. And x is greater than -3. So when I graph, I have to have 0 on my number line. And I have -3. What kind of a dot's at -3? Open. And then which way am I going to color? To the right. I want everything that's bigger than -3. And then your interval notation would just be parenthesis -3 to infinity. You go left to right. So here would my answer be. Okay, look at the next one. This is the same thing. We still have a linear inequality because x is to the first power. You just want x's on one side and numbers on the other. So doesn't matter. I'm going to add x to both sides. So I get 12 is greater than or equal to 8x. This is an add x. I don't know why it looks like that. Divide both sides by 8. And I get, what is this, 3/2? Greater than or equal to x. I personally would rewrite that. So x is on the left-hand side. I would write it as x is less than or equal to 3/2. And then I'm going to graph it. What kind of a dot do I have at 3/2? It's closed. Good. And then which way am I going to color? To the left. Good. So my interval notation, we go left to right, would be -infinity to 3/2. And I would have a bracket right there.
Hey, girl.
Hey, girl. Hey. Let's look at the next one. Same thing. We are linear. We have a linear inequality. X is to the first power, so move x's to one side and numbers to the other. I'm going to subtract 2x because I like x on the left-hand side. And then I'm going to minus 3. So I have negative 3x is less than or equal to negative 10. Divide both sides by negative 3. When I divide by a negative number, what do I do to the inequality sign? When you divide by negative, what do we do to the inequality sign? Flip it. Good. Good, good, good. So 10 over 3. So there's the first part of my answer. The second part of my answer would be, okay, I need to graph this. So I have 0. I have 10 over 3. If it's greater than or equal to, that means I have a closed dot. And which way am I going to color? To the right. Good. So if we're going from negative infinity to positive infinity, left to right, I'd write my interval notation as 10 over 3 with a bracket because it includes and goes to infinity. And there is my answer. Questions? All right, let's look at the next one. How is this one different? Duque, how is this one different? Why is 31 different, guys, than what we've done before? Because it has x squared, right? We have x squared as well. So when we have a quadratic, x squareds and x's, you want to get everything to one side. This is where you guys should tell yourself a couple things before you start. Look at your inequality sign. X squared minus 4x is what? What does that say? Less than, right? This is an and problem. That means when I graph it, I'm going to have 2 points, and I'm going to color in between. My 2 points are going to be closed, and they're going to be closed because it has the equal to sign underneath. That means on all of the numbers, I'm going to use brackets. Once you guys have that set up, now you just treat it like it's an equation. I'm going to subtract x and subtract 6 from both sides. So I have x squared minus 5x minus 6 equals 0. I'm just going to solve this. I have to find my critical points. So what times what is going to give me a negative 6 when I multiply, but a negative 5 when I add?
2 and 3.
I agree 2 and 3 will give you that combination of numbers, but will it give you the combination of signs? To get a negative 5 to add, you'd have to have negative 2 and negative 3, but that would give you a positive 6 when you multiply.
So you do 1 and 6. I mean,
Yeah.
yeah.
You could do x minus 6 and x plus 1. So you have 2 critical points at x equals 6 and x equals negative 1. So when I graph this, I have a point here, negative 1. I always have to have 0, and I have 6. And we said at the beginning, we were going to have closed dots, right? So close your dots up. And since it's less than, you're going to color here in the middle. And you have to check just to make sure you colored in the right spot. Always pick 0. 0 is the easiest one to do. So when you plug 0 into the original, should it work? Yes. How come? Because it's colored in. So go back up to the original. I have 0 squared minus 4 times 0 less than or equal to 0 plus 6. So this, guys, is 0 less than or equal to 6?
Yes.
Yes, it is. So that is true. So how would I write my interval notation for my graph?
You would put,
Negative 1, good. Comma 6. And what goes on either end? How come? Because it's or equal to. And this is what I'm looking for, guys, for your inequalities. This is what I'm looking for. Negative infinity or positive?
I know like the difference, but like when we're looking at doing that,
I'll show you in 1 second. In the and ones, that's when we color in between our 2 critical points. The or ones, great or, is when we go opposite ways. Did you get my text message?
No. I mean, I did, but I haven't looked at it.
Okay. Funny times, funny times. Oh, I forgot to finish this problem. Put, you guys want to do, let's do greater than 0. I forgot to finish the problem.
I need to put AirPods in.
Do what?
I need to put AirPods in.
Yeah. All right, so greater, that means or, right? That means our graph, look, Duque, is going to go in opposite directions. Is this greater than or equal to, or is it just greater? Is there an equal to sign underneath our inequality? So I have open dots, and when I have open dots, I'm going to use parentheses on my numbers. We always use parentheses on infinities. But on the numbers here, we're going to use open dots. So guys, look, we're going to treat this like it's just a normal equation. It's a normal quadratic that we have to factor. A times C gives me 30, yes? 2 times 15 is 30. What are the factors of 30 that multiply to give me a positive 30, but add to give me a negative 13? Okay, 15 and 2, agreed. But if I multiply a negative 2 and a positive 15, I'll get a negative 30. I want it to be positive. So think of some other factors. That's good. That's why I put this one on here, because it's a little tricky. Negative 10 and negative 3. Good. So x minus 10, x minus 3. And again, guys, our a term is not 1. So divide by 2. So I left with x minus 5 and 2x minus 3, right? So when I solve to get my critical points, I'm at x equals 5 and x equals positive 3 over 2. You guys with me on that? Do you need me, if I move the 3 over, it becomes positive, and then I divide by 2? So now when I graph it, watch, Duque. 0, 3 over 2, and 5. We said we have open dots. So open here, open here. Or means I shade in the opposite directions. So plug in 0 and see if it works. Should 0 work? Did I color over 0? Yeah. So should 0 work? Okay, so let's go to the original. Plug in 0. 2 times 0 squared is 0. Minus 13 times 0 is 0. So I get 15 is greater than 0. Is that a true statement? Yes. So my interval notation from left to right, how we read a book is how we're going to write our interval notation. So it's negative infinity to 3 over 2 with a parenthesis because it does not include it. And then I have my union sign, 5 to infinity. Do you see that? Because, yeah, the stuff on the left. You read it from left to right. Questions at home? Anybody? Can you hear me?
Yeah.
Okay, just making sure you're still with me. All right, let's look at the next. Just a couple more. Linear or quadratic? Is 33 linear or is it quadratic? Guys, is 33 linear or is it quadratic? Does it have x squared or just plain old x? It's got x squared, so that's quadratic. So we're going to treat this like we would a factoring problem. So the first thing I'm going to look at, it says x squared minus 4x is greater. That means it's an or problem. I'm going to shade in opposite directions, and I have closed dots because it says or equal to. So Duque, this is another one where you're going to have infinities. So guys, if I were to just solve this problem like normal, x squared minus 4x equals 0. What do you notice? What do you guys notice? What can I take out of x squared and 4x? I can take out an x, good. So I'm left with x minus 4 equals 0. So I have critical points at x equals 0 and at x equals 4. So 0 and 4. We said that they're going to be closed. And it's an or problem, so I shade in opposite directions. Now, if I use 0, should it work? Yes or no? Yes, because it's included. So when I plug in 0 here, 0 squared minus 0, is that greater than or equal to 0? Yes. So your interval notation from left to right would be negative infinity to 0, bracket, union, bracket, 4 to infinity. Our union goes where the gap is. So that would be our solution. All right, look at the next one. Is this the exact same problem? Yes or no? No. How's it different? Yeah, the inequality sign's different. It's less than. So that means it's a less than, an and problem. Ms. Carver, did you? Okay. What kind of dots am I going to have? Open or close? Open. Good. Since it's an and, I'm going to color in the middle, and that means I use parentheses on my numbers. So this is the same kind of problem like we just did. We set equal to 0, factor out the x. We have x minus 4 equals 0. So I have critical points at 0 and at 4. But you guys just told me they were open dots, and I'm going to color in between. So in this case, guys, think about it. If I plug in 0, should 0 work? Yes or no? Is 0 included? No, it's not included because it's an open dot. So 0 should not work. If I plug in 0 here, 0 squared minus 4 times 0, is 0 less than 0? No, that's not a true statement. So you would have 0 to 4 being your interval notation, but parentheses because neither 0 nor 4 is included. The sign makes a huge difference, meaning if it's less than or greater, the direction that you shade, and the open and closed dot. If you guys notice, those problems are very, very similar, just the inequality sign's different, and it changes your graph and your interval notation a whole bunch. All right, let's look at 35. 35 again is what kind of a problem? It's a quadratic because it's squared. So I look and I say, okay, this is greater, so it's or. I have closed dots because there's the or equal to, and I'm going to have brackets on my answer. So I'm going to move everything to one side. 2x squared plus x minus 10 equals 0. When I move the 10 over, it becomes negative. Let's factor. A times c, so negative 20. What are the factors of negative 20 that multiply to give me negative 20 but add to give me 1? Negative 20 when I multiply, but add to give me a positive 1. What would that be? Anybody? Anybody at home? What would that be? Come on. Kennedy, what would that be?
5 and 2.
Yes. Kennedy, tell me.
Multiplies
To give me negative 20, but adds to give me 1.
4 and 5.
Yep.
or
Perfect.
negative.
Negative 4, positive 5. Now, since my a term is not 1, I have to divide both by 2. So this, I'm left with x minus 2. And that doesn't divide pretty, so 2x plus 5 equals 0. So I have a critical point at 2 and a critical point at negative 5 over 2. Move the 5 over, it becomes negative. So now we're going to graph. Negative 5 over 2, 0 and 2. We said at the beginning we're going to have closed dots at both of those points. We're going to shade in opposite directions. Now check 0. Should 0 work? Did I color over 0? No. So 0 should not work. So when I plug 0 in here, okay, so should 0 work? No. So 2 times 0, 0 plus 0. So I have 0 is greater than or equal to 10. Is that a true statement? No. So we're correct and 0 shouldn't work. Adrian, I'm not picking on you. This is just a good time. What should I do for my interval notation?
Since it doesn't work,
Look at the color. Where did I color? Tell me how to write that. Left to right. Left. Start on the far left side. What do we?
So right now, parentheses is the negative, infinity.
Yep. So I go negative infinity, and I keep looking. My eyes keep going until I stop at what?
Negative 5 over 2.
Perfect. And it's going to be a bracket because it's closed, right?
And then you're gonna have another, you're gonna have a U, and then you're gonna have a bracket,
Perfect.
and then you're gonna have 2, and then infinity.
Perfect.
And then parentheses.
Perfect. So do you see when you have the infinities and the parentheses and when you, okay, good. Good, good, good. Everybody at home, how are we doing? Okay. All right, a few more. All right, is this a linear inequality or is this a quadratic? Linear, because it x is to the first power. Okay, good. You're going to have both of them, so I want you guys to understand how they look different. So I'm going to subtract 5 from everything. So I have negative 6 less than 2x less than or equal to negative 2.
Yeah.
Okay, divide everything by 2. So I have negative 3 is less than x, which is less than or equal to negative 1. So on my graph, I have negative 3, negative 1, and 0. Whoops. What kind of dots do I have at negative 3 and negative 1? Good. Open at negative 3 and close at negative 1. Very good. And where am I going to color? In between, because x is in the middle. So your interval notation would be from negative 3 with an open parenthesis to negative 1, and that would have a bracket. And there is our answer. When we have a linear inequality, you have kind of 3 answers. You have the inequality itself, you have the graph, and you have the interval notation. When you have a quadratic, the only thing I'm looking for is the graph and the interval notation. All right, again, this is an easy one. This is greater, so it's or. I'm going to go in opposite directions. Open, because there's no or equal to underneath my inequality. And I'm going to use parentheses. So what are the factors, guys, of negative 12 that multiply to give me negative 12, but add to give me 4? 2 and 6. Good. X plus 6, x minus 2. So I have critical points at negative 6 and at 2. We said there were open dots because there's no or equal to. Or means we color in the opposite direction. Now when I plug in 0 to check, should 0 work? No. So when I plug in 0 here, I get 0, 0. Is negative 12 greater than 0? No. So we're good. So my interval notation would be from left to right. Negative infinity to negative 6, parenthesis, union 2 to infinity. Questions, comments, concerns? How we doing at home?
Good.
Okay, good. I've already done 39 for you last week when we were going over things. I'm going to do 38. Every person, all right, there's like 9 different versions between Ms. Glick's class and my class for this test. Every single version, because I made them, has a question like this. This question is fairly straightforward. It's already set up for you, critical points and all that stuff, but you guys have to show me the work. So what you need to do in a case like this is you have to graph the critical points. You have a critical point at 5, one at 2, and one at negative 1. You just set each parenthesis equal to 0. So on my graph, I have a point at negative 1, I have 0, I have 2, and I have 5. What kind of dots do I have at negative 1, 2, and, 5? I get the hiccups. Open. How do you know they're all open? There's no or equal to underneath. Perfect. Good job. So guys, kind of look at like this as sections. All right, in order for you to get credit for this and show your work, you need to do something like I'm doing now. First thing I'm going to do is I'm going to set up my problem. X minus 5 times x minus 2, x plus 1. Is that number that I get less than 0? Pick a number to the left-hand side of negative 1. I'm going to pick negative 2. So if I put negative 2 right here, guys, negative 2 minus 5 gives me negative 7, right? Then I plug in negative 2. I get negative 2 minus 2 gives me negative 4. Then I say negative 2 plus 1, and I get negative 2. The value, the numeric value of that number doesn't really matter, because all we're doing is comparing it to 0. If I have a negative times a negative, what does that give me? a positive, times another negative. It's going to give me a negative number. If you guys want to work this out and say, okay, -7 times -4 is 28, and times -2 is -56. Is that a true statement? Is -56 less than 0?
Yes.
Yes, so stuff over here works. So now you got to try something in between -1 and 2. Well, 0 happens to fall in between -1 and 2. So let's do that. That's easy. So I have, if I plug in 0 here, I get -5. If I plug in 0 here, I get -2. And if I plug in 0 here, I get +1. -5 times -10 times 1 is 10. Is 10 less than 0? No. So nothing in here works. If you guys want credit for this problem, this is how you have to do it. You can't just say, oh, I did it in my head. No work, no credit. Now pick a number between 2 and 5. 3? Okay. So I have 3 minus 5, 3 minus 2, and 3 plus 1. Is that less than 0? Well, 3 minus 5 is -2. 3 minus 2 is -1. And 3 plus 1 is 4. So -2 and -1 is 2 times 4 is 8. Is 8 less than 0? Yes or no? Okay. Oh, guys, hold on. Time out. Back up. What's 3 minus 2? +1. +1. So I have +1 and then 4. -2 times 1 is -2.
Yes.
Times 4 is -8. Is -8 less than 0?
Yes.
Yes, so that works. And now pick something bigger. Bigger than 5.
6.
Okay, 6. So we'll plug in 6. 6 minus 5. 6 minus 2. 6 plus 1. Is all that less than 0? 6 minus 5 is -1. Okay, so -1. 4. Yeah, why am I saying that? Ay. Sorry, 6 minus 5 is 1. Then I have +4, and 6 plus 1 is 7. So 1 times 4 is 4 times 7 is 28 less than 0. No. So where are the two places on the graph that the solutions are? Where do they exist? In between where and where? Say it again. Infinity, negative infinity to -1, and where else? And between 2 and 5. So this is what I would expect to see for your answer. I would expect to see shading where your answers exist and your interval notation. So as you read from left to right, it would be negative infinity to -1 with a parenthesis. It does not include -1. Then I have a union. And it works again from 2 to 5, parentheses. That's the only place on this graph that you could pick numbers and it would satisfy the inequality. Questions? Last period when we were doing this. Can you go over the rules again real quick? I'll write this down so you guys can see it. If you have less than or equal to, greater than or equal to, you're going to have closed dots, which means it includes that number. And you're going to use brackets on the numbers that it includes. So your dots will be closed. That means it includes the number, and you'll have brackets. If you have less than or greater than, it's going to be an open dot or open dots. It doesn't include. And you're going to have parentheses on the numbers. Anytime you have infinity, negative infinity or positive infinity, infinity always has parentheses on negative or positive. So make sure you guys know that. Make sure you have that written down, got it in your brain, something